All right, so recently we've been studying how to solve quadratic equations by factoring. So what we're going to do today is we're going to take a look at an example and we're going to try to solve it by factoring. So the example that we're going to look at is one that's found here in part one. So it says solve 2x squared plus 20x minus 8 equals 0 by factoring. So let's go ahead and try and do that. So we've got 2x squared plus 20x minus 8 equals 0. So since this is an equation and I see that there's a greatest common factor, what I'm going to do is I'm going to divide both sides of the equation by 2, which is the greatest common factor. And it just makes factoring that much easier when the leading coefficient is equal to 1. All right, so there we go. So we're down to x squared plus 10x minus 4 equals 0. So what I'm going to do is use the Xbox area model method to try and factor this trinomial. So I'm going to multiply the constant term, negative 4, times the quadratic term, and I'm going to get negative 4x squared. And what I'm going to be looking for are factors of negative 4x squared that add up to positive 10x. So I'm just going to write on the left-hand side here, negative 4x squared. Now let's think about some factors of negative 4x squared, where you can multiply negative 4x times x. But if you add those together, that equals negative 3x and not positive 10x, which is what we're looking for. We could also do 4x times negative x. And again, if we add those together, we get positive 3x, which is not going to give us that middle term 10x. Our other options would be, negative 2x and 2x or 2x and negative 2x, which is really the same thing. We add those together, we get 0. So it looks like there's no combination of factors of negative 4x squared that are going to add up to 10x, which means that this trinomial, 2x squared plus 20x minus 8, is not going to factor nicely. So the question becomes then, well, how do we solve equations if we can't factor the trinomials nicely? This equation does have answers. And what I did is I graphed the function on Desmos so we can see. All right, so you can see that the graph of the quadratic is intersecting the x-axis. Looks like x equals about 0.39 is one of the x-intercepts and negative 10.385. So let's go back to the notes. So the solutions to this equation are x is approximately 0.39 and x, I should say, or x is approximately negative 10.39. So we know that there are solutions to this equation. The question just becomes, well, how do we find those solutions? So the key is actually in something that you just studied, which was this idea of perfect square trinomials. So really what our focus is going to be over the next couple videos is trying to make expressions into perfect square trinomials and then taking square roots so we can solve equations. Let me show an example right here. So x plus 2 all squared equals 15. Well, x plus 2 all squared follows that perfect square trinomial pattern. If you were to, expand that, if you were going to do x plus 2 times x plus 2, that would follow, the result would follow a perfect square trinomial pattern. So the question is, how do we solve this equation that we're looking at? Well, what I would do is take the square root of both sides. And we used a technique like this in the last video. So we need to remember that in front of that square root, we have to put a plus or minus. Anytime we take the square root of both sides of an equation like that, we need to make sure that we put a plus or minus in front. Then we're going to subtract 2 from both sides. And this is what we end up with for solutions. So you get two solutions out of this. You get x equals negative 2 plus the square root of 15, or x equals negative 2 minus the square root of 15. So those are our two solutions. Now, if I were to approximate those with a calculator, this would be approximately 1.87, and this other root would be approximately negative 5.87. So the idea here is, how do we make the equation in part one? How can we rearrange this equation? I'm going to highlight it for you. How can we rearrange this equation and make it look more like this equation right here? Because the equation that I just highlighted in blue from part two is really easy to solve. We can just take the square root of both sides and we're going to get our answer. So even though the answers aren't really nice numbers, 1.87 and negative 5.87, the equation still has solutions and we can get them pretty easily. So let's take a look down here on the bottom, and we're going to try to kind of answer that question right now. So let's walk through this. How do we make this equation look more like something like that? All right. So we're going to start off with 2x squared plus 20x minus 8 equals 0. And we're going to divide both sides by the common factor again. So if you can get the leading coefficient to equal 1, then that's really what you want to try and do. So we're going to divide both sides by 2, even if that means that you get some fractions for your other coefficients. So we get x squared plus 10x minus 4 equals 0. The next thing that we're going to want to do is we're going to want to isolate any terms that contain variables. So we're going to get our variable terms on this side, on the left-hand side, and our constant term on the other side. Now, I just want to give you a heads up that this is a technique that I'm going to go over in greater detail later on in other videos. I'm just trying to demonstrate it for you right now so you have an idea of what direction we're going to be moving in when we try to solve these equations that we can't factor in the future. So don't panic if I'm going too quickly here, because I will break this down further in later videos. All right, so the next thing I'm going to do here is I'm going to add a number to both sides of the equation. I don't know why it didn't give me a different color. Let's try that again. So I'm going to add a number to both sides of the equation. Now, the idea here is that I want to add a number that is going to make this right here a perfect square trinomial. Because if that's a perfect square trinomial, what I just highlighted, then we can factor it to make it look something like that. And you'll see what I mean in just a second. All right, so what I'm going to do here is try to figure out the number that's going to make that a perfect square. Now, if you remember, we need the dimensions of our area model. If this is going to be a square, we need the dimensions to be exactly the same. Well, how do we do that? So we're dealing with these two numbers right here that I've highlighted or underlined in green. So what I'm going to do is I'm just going to cut both. I'm going to divide both of those in half. So I'm going to take x and divide that by x. That's going to give me this and this. And then I'm going to take that middle term and I'm also going to divide that by in half. So now what I'm doing is I'm looking for this constant term that will make this a perfect square. So if we look, we know x times x is x squared. 5 times x is 5x. 5 times x is 5x. If we add 5x and 5x, we get 10x, which is good. Now we need that last term. And this last square is a 5 by 5 square. And if we multiply that together, we get 25. So the number that's going to make the left-hand side a perfect square trinomial is 25. So I'm going to add that to both sides. So now what I'm going to do is I'm going to factor the left-hand side. And it's really easy to do that because we already have our area model on the right. We already have it. I'm circling it in blue right now. Okay, we have that right there. So that factors to x plus 5 times x plus 5, which is x plus 5 squared. And you can see that those dimensions in our area model. And now that's going to equal negative 4 plus 25, which is, actually, I'm sorry, that should be a positive 4. Positive 4 plus 25, so that's 29. And now if you notice, the equation that I just wrote in blue looks a lot like this equation up here that I just circled in blue. All right, so now we can solve this by taking the square root of both sides. And we're going to get x plus 5 equals plus or minus the square root of 29. And then we're going to subtract 5 from both sides. And again, we're going to end up with two results. And those results are x equals negative 5 plus the square root of 29, or x equals negative 5 minus the square root of 29. Now, if I were to simplify those with a calculator, these are the numbers that I get. I get x is approximately 0.39, or x is approximately negative 10.39. And those are the exact same answers that we got graphically from Desmos. If we look back up at the top, they're exactly the same as these two numbers right here. Okay? This process that I just demonstrated is called solving a quadratic equation by completing the square. And this is what we're going to be working on over the next couple videos, and you're going to practice for good 4 or 5 days. It's also going to lead us into one of the most important ideas that you're really ever going to study in mathematics. And I don't want to be too dramatic about that, but it is true. All right, so if you're a little bit confused, that's okay. We're going to be spending some more time on this, but this kind of just gives you an idea of the direction that we're headed in. So I hope this was helpful. If not, it should all come together pretty soon, and we will see you in the next video.